Assalamualaikum warahmatullahi wabarakatuh. We are from Group A 4C S112 4C, Diploma in Actuarial Science, would like to present our case study with the title, The Application of Linear Algebra in Calculating the Spread of Covid-19. Our group members, which are Fatia Yasmin, Intan Shakira, Nur Atika Huraya, Nuri Izzati, Nur Hamiza Hafni, and Ahmad Azizan. The COVID-19 pandemic has caused a new normal to be practiced, ensuring the safety of all. It has opened up discoveries about this newly virus infection that has struck a unique environment of ways to develop modeling techniques to undergo advanced studies of this well-known virus. In this study case, representatives of the linear algebra techniques will be used to calculate the spread of COVID-19.
Next is purpose. The purpose of this study case is to understand, predict, and calculate the spread of COVID-19 to help us make the best decision. A mathematical model, Markov chains, will be used to analyze how the virus spreads throughout the population, therefore can help to understand the virus behavior when it enters and is transmitted in a community. The analysis will aid in predicting and calculating the daily number of healthy, infected, and dead people during the pandemic.
There are 6 assumptions made in this analysis. First, the initial numbers of healthy, infected, and dead people are 10,000, 0 and 0 respectively. The size of the population remains unchanged throughout the analysis. Third, the probabilities are as follows. Healthy stays healthy 0.89, healthy to infected 0.1, healthy to dead 0.01, infected stays infected 0.75, infected to healthy 0.05, infected to dead 0.2, dead stays dead 1, dead to healthy 0, dead to infected 0. The fourth assumption, the probabilities of all events are constant throughout the analysis. The numbers of healthy, infected, and dead people be calculated for a week, 7 days. All calculated numbers of healthy, infected, and dead people be rounded off to the nearest integer. So, how to solve? First, a diagram representing 3 states of Markov process is drawn with the states labeled as healthy, infected, and dead. The numbers at the arrows represent the probabilities of the Markov process changing from its initial state to another state. Then, the probabilities of all events are arranged in a transition matrix N. A vector F is created with the numbers of healthy, infected, and dead people placed in it. Then, the vector F is multiplied with transition matrix N to get the new numbers of healthy, infected, and dead people.
For result, the diagram representing 3 states of the Markov process is drawn, with the states labeled as healthy, infected, and dead. By compiling those probabilities in the diagram before into a table, we get the following transition matrix N. Then we create a 1 times 3 vector F, which contains information about 3 different states any current day is in, where column 1 represents healthy people, column 2 represents infected people, and column 3 represents those who died. In this study case, the resulting vector for the current day is F equal to 10,000, 0, 0. Given the state of the current day, we can calculate the possibilities of healthy, infected, and dead people from the 1st until the 7th day. That can be done by multiplying the vector F with the transition matrix N, giving the following. Next, for the second day, we will take the number of healthy, infected, and dead people from the first day as the new vector F and multiply it with the transition matrix N. This step will continuously repeat for the next day until it reaches the 7th day.
Next is discussion. In this study case, initially there are 10,000 healthy people in the country. We predict of what will happen in the long run. Suppose that 10% of healthy people will get infected by the virus. Even if there is a cure for the virus, it is not always guaranteed to work. So we assume that every day, only 5% of the infected person will recover. Hence, we are assuming 20% of infected people will die. When the condition of the infected people gets worse, eventually die from the virus. Due to rare cases where perfectly healthy people do not show any symptoms but suddenly die as they have been infected by the virus, we will assume that 1% of healthy people may die from the COVID-19. The numbers in the transition matrix N remain the same, but for vector F, the numbers are different each day. However, if all of the numbers of healthy, recovered and dead people are added, the total number of people will still be 10,000 as the size of the population remain unchanged. Therefore, the Markov chain method used in this study case is a linear algebraic way of calculating the spread of COVID-19.
Conclusion. In conclusion, by reading many materials and watching videos explaining the theory and calculation regarding Markov chains, the problem encountered can finally be overcome. Markov chains can help us to understand and calculate the daily number of infected, recovered, and dead people according to probabilistic rules. By applying these two methods, the number of COVID-19 cases and their patterns can understood and calculated more easily, which has made predictions to be much more accurate and applicable to real-life situations. That's all from us. Thank you.